Okay, so as you can see there, the title is molar mass. And molar, right, when we put AR on the end, it simply means pertaining to the mole, right? So what we want to talk about today is the mass of a mole of substance. We've already talked about how we determine the mass of a formula. We calculate the formula mass. Remember, it had all those arrows underneath it. We're going to do the same here in a moment, but this time we want to talk about how much an entire mole weighs, not just a single entity. Because when we do the formula mass, what's the unit when I do the formula mass of something? What did I put at the end of that formula mass? It was a couple of lessons ago. What was the unit on the end of the formula mass? Yep. A U, which is, remember, an atomic mass unit, and that's a tiny little fragment of a carbon-12 atom, which we represent as 1. And so when we determine the masses, we're really talking about tiny little masses, the masses of an entity, the mass of a molecule, or the mass of an ion, or the mass of an atom. Again, the whole purpose of coming up with this idea of the mole is so that we can work with materials that are large enough that we can actually handle and measure. So we can weigh out a mole of water, and we can weigh out a mole of carbon if we want to. So what we need to do first here in the beginning of this lesson is to look at the concept of how much does an entire mole of a substance weigh, all right? And this mass is called a molar mass. And this is a very important and very useful mass. So let's define what the molar mass is. Molar mass is the mass in grams of 1 mole of a substance. It's pretty straightforward. Entities are too small, so we put them into these big groups of entities called moles. And now we want to know what's the mass of a mole of a substance. The symbol is MM, stands for molar mass, not too surprising, and it's going to have a unit of grams per mole, or grams per 1 mole. Now this next slide, I asked you to determine the mole of 1 mole of carbon. Don't write this down. I'm going to show you where this particular number comes from, and then I'm going to show you a shortcut. And so the example that I'm giving here, it does not need to be written down because it's not the way you're going to find the molar mass every time. It's the way to the shortcut. I found when students write it down, sometimes they get confused and they think that's the calculation I want, and I don't want you to have this. I just want you to see this. So in my example, I'm asking you to find the mass in grams of 1 mole of carbon. Now, the way we can do that is we need to get some information together. We need to get some conversion factors together. We know that carbon has a particular mass. What's the mass of carbon? Yeah, Chelsea? 12. And what's that unit? 12U. 12 atomic mass units. All right? I also know that if I want 1 more, and this is the mass of what? This is 12U, and it's an entity, isn't it? It's a little entity. It's an atom of carbon. It's 12U for 1 atom, right? Again, don't write this down. If I have a mole of the substance, I can write the conversion factor. If I've got 1 mole, how many atoms am I talking about? How many atoms is in 1 mole? Yep. 6.02 times 10 to the 23. 6.02 times 10 to the 23 entities, or atoms. So if I'm talking about, if I'm starting with 1 atom, which is 12U, 12.0U, I eventually want to get to a unit of grams for 1 mole of that substance. Now, I do not have a conversion factor that converts U to grams. I have a conversion factor that will convert atoms to U, but I need one more conversion factor, 1U. And this conversion factor I used to teach in great detail. We used it quite a bit, but it really doesn't serve a lot of purpose. 1U is a very tiny mass unit. It's on your chart, but you don't really need it. It says 1.66 times 10 to the minus 27 kilograms, the atomic mass unit. I want it in grams. 1.66 times 10 to the minus 24 grams. Okay? This is U per 1 entity. Can I manipulate these conversion factors to get me a unit of grams per mole? Let's take a look at the U here. Do I have a conversion factor that has a U in it? Where do you think I'm going to have to put that U if I want to get rid of it? Where's the U going to have to go in my conversion factor if I want to get rid of it? Brendan? In the bottom, right? 1U is equal to 1.66 times 10 to the negative 24, and that is entities. No, sorry, that's not entities. That's grams, right? Yep. And that's kilograms. And if I then put it times 10 to the 3 with that negative 27, it makes it negative 24 grams. Okay? All right? So now my U's are gone, and I've got my grams. What do I need to get rid of in order to complete my conversion of this unit of U's for 1 entity into grams per mole? What do I have to get rid of in this unit? What do I have to cancel away, Janessa? Entities. I have a conversion factor that has entities in it, right? Where's the entities going to have to go in order to get rid of that entities? On the, if I put it on the bottom, notice, yeah, I got to put it on the top on this case. This is the first time we've had to kind of flip it around. That's okay. It's a little different. I'm not going to make you do this every time, but 6.02 times 10 to the 23 entities with 1 mole. Now my entities are gone. What are the only units that I have left here in my whole calculation? What are the only units that are residing at this point? Yep. Grams on the top and moles on the bottom, right? Which means if I put all of these things together, I should then have the mass of 1 mole of a substance. Go ahead and do that calculation. 12.0 times 1.66 times 10 to the minus 24 times 6.02 times 10 to the 23. Use your EXP buttons the way I taught you how, right? Do it all properly. Again, you don't need to write this stuff down. I just need we just need to actually calculate it in order to make some sense out of it. So, 3 significant digits, 3 significant digits, 3 significant digits, to 3 significant digits. What do we have as an answer? What does that round to? Everybody's looking around. Everybody's wondering. Emily dives out and tells me. 1.30. Nope, no, there's an error there. Atlee? 12.0. 12.0. We get 12.0? The mole, its value has been chosen so that if you calculate the mass of 1 mole of a substance, its mass number will be exactly the same as its formula mass number, except instead of the units U, it will have the units grams. That's why they chose the size of the mole to be what it is. That's why the mole is not necessarily 1 times 10 to the 23. It's 6.02 times 10 to the 23, because when you gather up 6.02 times 10 to the 23 entities of anything, its mass will be the same as its formula mass, except in grams per mole. Now that's a helpful thing, because now instead of writing down U's, which is a really tiny number, we can write down grams for 1 mole of that substance. What this does is allows us to change our thinking of our chemistry speak. At this point, we talk about taking molecules of hydrogen and molecules of oxygen to produce molecules of water. But now we need to think, instead of tiny little molecules, we can say moles of hydrogen reacted with moles of oxygen to produce moles of water. And the amounts that we will be dealing with will be in the grams. We'll be actually able to put it on a scale and say, I have 1.5 moles of a substance because I know what its mass is. So the molar mass allows us to, instead of thinking of tiny little things, we can think of actual amounts that we can put on scales and we can measure. All right? So let's do some practice getting some molar masses. So find the molar mass of. You can change that to number 1 if you'd like, because I actually didn't do number 1. Now you might think that, oh man, I have to do that complex calculation. That's why I didn't have you write it down. I said, don't write that down. Because what I now need you to do is do exactly what you did for the formula mass, except now you have a new unit on the end of it. So ammonium sulfite, that's just to be mean, just to see if we're on the ball, right? I changed it to a sulfite. That's kind of mean on that. Ammonium, what's the formula for ammonium? Yep, NH4. NH4, what's a sulfite? SO3. SO3 with what charge? So it's 2, which means I got to cross over 2 over here, right? That's just kind of mean to start with. So when I say determine the molar mass, you're not thinking about that great big calculation. We now can go straight to the shortcut. All we have to do is do exactly what we did for the formula mass, except now we have a new unit, a more useful unit. Again, round to the first decimal, just like we did with the formula mass. 16.0 times 3. Sulfur, I can't remember. 32.1? 32.1. Hydrogen, 1.0 times, it's looking like an 8. What's nitrogen? 14.0. And that's just times 1, no need to write that down. What did I do? Oh, it's times 2. Woo, times 2. I dropped the ball on that one. Times 2. Run it through your calculator. Again, this is the type of thing that's going to be something that you're going to need to do just as an aside. This is like a tool. And we'll take the number when you get it. Yep. 116.1. 116.1. And here's the big difference. The unit is grams. Grams per mole. And when you write it in your head, think it. Grams per mole. You can even move your lips if you'd like. That's what I do when I read. I'm a slow reader. It's really sad. I got to use my finger across the line too once in a while. Grams per mole. Notice, look at this unit. It's a compound unit. It's kind of like kilometers per hour. I can use that as a conversion factor, and we will in a moment. What am I going to be able to convert between if I have a unit like grams per mole? Grams and moles. That's a very useful thing. That means now we can determine the number of moles in a substance instead of by using this great big number, by determining how much it weighs. If I know the mass of a substance, if I know its molar mass, I can turn it into the moles of a substance. And now I know how many of those moles there are. Calcium nitrate. Does somebody have a formula? As I've been babbling on here. Oh, you guys listen so well. Pausing for a calcium nitrate. Emily, what do you got? We're doing the same thing as formula mass. We're running it along there. The only difference is the new unit. And the unit is very important because in a moment we'll use it as a conversion factor, and then we'll be on our way. Don't wait for me. The more you do, the more you'll have them memorized. It's quite sad. I know the molar masses of a lot of the top 20 just in my head because of using it over and over again. That's why practice makes you faster. Calcium, we used it yesterday. Did anybody know that from without looking? Anybody remember it? I do. Anyway, what do we got? Yep, 40.1. Somebody have the number? Yep. 164.1. And what's the unit? Grams per mole. We want to say it almost like we're zombies, like our brains are not even functioning anymore. We're just saying it. We're just falling out of our mouth. Grams per mole. All right. Don't worry about the carbon tetrachloride. Now, notice there it says, go to the handout and do the grams per mole, do the molar mass problems. You're not going to do that. I'm going to now continue and use that. You can do that for some homework. All right? Because really, it's the same thing as the formula mass, except grams per mole. Okay? Let's now actually use this molar mass as a useful conversion factor. There's the answers again, right? You'll be able to go back and check those. Okay. Calculations involving the mole and conversion between mass and moles. This is one of the more important conversion factors. If we're doing a reaction in a lab, I'm really not worried about entities anymore. I can't actually see a molecule. I can't actually grab a molecule. But I can see a mole worth of molecules, and I can weigh a mole's worth of molecules. So even though I taught you Avogadro's number first, this isn't the most important conversion factor. At this point, the molar mass is the most important conversion factor. That's not to say we're not going to still use this one. Definitely going to still use this. But this is useful in a laboratory. I actually am going to add that at this point to our little chart paper here. So number 3. And again, you do not necessarily have to write this down at this point, but you might eventually. Oh, look at it. That's really bad. I put NA for not available, and there's an NA right up there. That's really bad, isn't it? That's totally confusing. Getting rid of that. That's confusing. Just nothing. Just leave it at nothing. We can write a map for this one. If I want to convert from moles to grams or back, What's the conversion factor called that I use to go from moles to grams? Excellent. This is where I'm going to indoctrinate you. Here's what I mean. Mathematics, the science of, or the subject of math, they're very good at mathematical indoctrination. They make you do all these problems. They make you do piles of them. You play little games. You do all this little stuff on the calculator. Let me give you an example. What's the equation of a line? Just tell me if you know it. Yeah, so I had multiple people, y equals mx plus b, right? They're good at that. You do that forever, y equals mx plus b. You guys even, tell me, what does the m stand for? See, in unison, the slope. You have no idea what to do with that, but you've got it in your head, right? What's the b stand for? I gave it away. Y-intercept. You know, I could say, what is a y-intercept? I don't know. But b is the y-intercept. So mathematics is great at what I would call educational indoctrination. You don't even know why you're saying it, but if somebody asks you the equation of a line, y equals mx plus b, whoa, what happened there? I have no idea. I need to indoctrinate you. If I ask you, how do you convert mass to moles or moles to mass? I need you to, in unison, in your best zombie voice, I need you to say, what is it? That's the unit, but what do we call this conversion factor? The molar mass. That's what I need you to say. Let's practice together here. How do I convert grams to moles? Very nice. Very good. It even sounds like church, right? That's what indoctrination is. Everybody, molar mass. Oh, molar mass. It's very holy in the chemistry world. What's that? Do you? All right. Okay, that's good. All right. Molar mass. The conversion from mass to moles is the molar mass. Second important thing, where do we get a molar mass from? What's the starting point? What's the first thing I got to have to determine the molar mass? The atomic masses are on the periodic table. I'm a little early on the game on this one. If you don't get it, it's not a big deal. You need the chemical formula. You need that formula in order to get those masses. So a molar mass has got to come from a chemical formula. So an example here, let me just put CO2 as an example. You don't have to write this down. You can write it down later. 16.0 times 2, and this is going to be 14, and I think that gets me 44.0 grams per mole. All right? And so in order to have a molar mass, you must start with the formula. Need chemical formula. Okay? And once you've got that chemical formula, you can then write that as 44.0 grams per 1 mole. Okay? Yep. It can't possibly be 46. I've got the wrong mass for something. Right, that's 12. Because I know that the molar mass of carbon dioxide is 44. So it can't possibly be 46. So I've made a mistake somewhere. Okay, let's do some examples. E.g., again, just write E.g. So in this question, I'm given a number that contains the unit grams pertaining to magnesium hydroxide. I want to find information about moles. I need to convert from grams to moles. What conversion factor allows me to convert from grams to moles? Very nice. Very good. Where do I get the molar mass from? The chemical formula. The chemical formula. I'm just going to ignore some of the stuff that Brendan comes up with. When he says something, just disregard it. And if it's right, I'll pat him on the back. The formula. Now, some of us hopefully are looking at that question and thinking about what I've been talking about and know we need the molar mass. For those of us who need maybe some guidance and you've memorized that math, you're going to write down something like this. Now, you don't have to write this. But if I'm starting with grams and I want to convert it to moles, how do I convert grams to moles? Yeah, see, very good. Molar mass. Where does the molar mass come from? It comes from the formula, which means I need a magnesium hydroxide. So now I'm doing two problems. I'm getting the molar mass, and then I'm going to use it as a conversion factor. I always like to put my molar masses off to the right side of the page just to get it out of the way. I need a magnesium hydroxide formula. Yep, Chelsea? MgOH2. And now I'm going to do the 1.0 times 2, 16.0 times 2. Pardon for squishing it up against the side. Magnesium, 24.3, 24.3. And I'm getting that calculator out, and I'm flying through that calculation as fast as I can, because really, that's just the beginning of the question. I'm not even really doing the question yet. That's just the tool I need in order to do it. I'll take the number as soon as you get it. Yeah, Haley? 58 point, and I lost the end. 3 unit. Yeah, very good. Like a zombie. I like that. That was good. I don't know if that was intentional, but it sounded great. Grams per mole. And it's very important that you write that down, because now we're getting ready for our conversion. Write down the number we're starting with, 56.8 grams. Be specific, MgOH2. So we're going to put that formula in there, just in case we need to find entities of hydroxide or something. That's not what this one asked, but we could go that far if we had to. Times. Now, my math tells me I need the molar mass. I have grams right there. I need someone to tell me where to put the numbers in this thing. I have 58.3 grams per 1 mole. That's my conversion factor right there. I can flip it over if I need to, or I can write it right side up. I don't write the 1 mole, but it's implied. Grams per 1 mole. The number goes with the grams. I have grams right here. What do I have to put and where? Brody? 1 mole on top and 58.3 grams on the bottom. I flipped it around in this case. My grams are gone. And if I check my units, I have moles of MgOH2. That's exactly what I wanted. That's going to get me the correct answer. And I'm squeezed out of room here. Checking significant digits, 3 and 3. So we're going to round to 3 significant digits. What do we have for an answer? Maggie, what do you got? 9, 7. Now, that's actually only 2 significant digits. If you were to convert that to scientific notation using your calculator, you'd notice you'd have to keep 1 more after that. You could do that every time if you'd like. I would accept scientific notation for every answer, but it doesn't have to be. That isn't a significant digit. That's just there to tell us where the decimal starts. So I need 1 more after that. 4? Did you say 4 and I missed it? Oh, okay. 974. 974 moles of MgOH2. Okay? If you're never sure of how many significant digits, you can convert it to scientific notation with your calculator and then just round to the 1, 2, 3, right? Let's do another one. Again, a map is not required. The reason I do the maps is because sometimes we need to take multiple steps. If you need to think of a map and write it down, you can. But notice it says, find the mass of 1.45 moles. How am I going to turn those moles into mass? What do I need? Molar mass. Where does it come from? Chemical formula, and everything starts to roll from there. Okay? Which means I need a sodium sulfate. You guys go ahead. Go ahead of me. And if you struggle with determining formulas, like I said when I taught you how to do formulas, that it was going to come back and get you, you need to know how to find a chemical formula. It's the ones without the decimals. I think that's a what, 32.1? You already have numbers for me? Oh, slow down there. Let me write some stuff down. 32.1, there's only one. Sodium is what, 23.0? 23.0, that's a times 2. All right, Brody, what do you got for a molar mass? Unit? Grams per mole, and you got to write it. That's your conversion factor, right there. Write down the information you're starting with. What's going where to complete this calculation? Jory, what do you think? Yeah. Yep. Yep. Excellent. And I'm out of room, so we'll just put an equals there and I'll put it underneath. 3 significant digits. 4 significant digits, so I'm going to round back to 3. Brody's on fire here, or what do I do? You're right, thanks. We'll take a number when you get it. A little harder to do the power of 10 estimation on this, but like this is in the hundreds, this is 1, so you're going to be into the hundreds still, I would think. Aren't you? Hundreds of grams? Yep. Yep, Brody, what do you got? 206? 206 grams. And if that 6 is rounded correctly, then that's 3 significant digits. That 0 in the middle just means we have 0 tens. Right? That's not a big deal. And technically it's grams of Na2SO4, just to be very specific. All right? So that's how we use the molar mass as a conversion factor. Hold on one second. Oh, do we want to stick a kilo in there? Yeah, let's do that. Let's do that. Just to keep us on our toes. Because I'm not going to let you work still. I'm going to give you homework, but not let you, because the last part of it is to put together all of our conversion factors that we've learned. We should be able to go from mass to moles to entities to atoms. We should be able to put them all together and figure out, how many atoms are in 25 grams of hydrogen gas, right? We should be able to calculate that out. This little example deals with the prefix kilo. And we can do this in a couple of ways, and I'm going to do this in a certain way to show you. Again, moles to mass, what do I need? Molar mass, and therefore, what do I need first? The chemical formula, calcium carbonate, CaCO3. Again, you'll notice this is now becoming something that I need done just quickly and off to the side. If you need a molar mass, go and do it. Get it out of the way. 16.0 times 3, 12.0. Calcium, I think, is 40.1. And Brody is taking over here. 100.1 grams per mole. Your cousin Jess was the same way last year. She was the Hermione Granger of the class. Brody is now Hermione Granger. Many of you give up because you think Brody's going to come up with the answer. I say make it a contest. See if you can get your hand up before Brody's hand up goes up. See what you can do. All right. Now, write down what you have. 1.00 kilograms of calcium carbonate, CO3. We want to turn it into moles, right? Now, there's a couple of things we can do. We could change that kilo into what? But what do I need to put instead of the kilo? I've got a kilo in there. What does kilo stand for? It's on your sheet, but it's here as well. What's kilo stand for? 10 to the 3. I could rewrite that as 1.00 times 10 to the 3 grams. But I'm going to leave it right now because we can actually leave it as a separate unit. Let me show you. You'll notice within the kilograms, there's a grams. I can cancel away just the grams if I'd like. I have to put the grams on the bottom so I can cancel it away. 100.1 grams for 1 mole. And if I do that, I'm going to have grams gone. And if I calculate that out just the way it is right there, and I'm going to ask you to do that, what is my unit going to be? All of the little pieces of the unit, let's put it together. Whatever's left that isn't numbers, put it together into a useful unit. What am I going to have? Brody? Sorry, I don't know why I did that, because Brody put his hands up first. I'm going to have kilomoles. If I calculate it out just the way it is, I'm going to have kilomoles of calcium carbonate. Go ahead and do that calculation and just give me the number you get from that calculation, leaving the kilo right into it. Emily, what do you got? 9 point, no, it can't be because I'm taking 1 and I'm dividing it by 100. Did you turn it into grams on me? Did you convert it into grams first? So you did 1 divided by 100.1? Is that in scientific notation?
Oh, yeah.
Yeah, that makes some good sense there. That's better. 99? Yeah. 99 times 10 to the negative 3 kilomoles. All right? If you didn't write it as that, you would have 0.0099, right? Kilomoles. Okay. Let's say we wanted to turn that back in to moles. 9.99 times 10 to the minus 3. That's my number. What does kilo stand for again in terms of powers of 10? Yeah, Janessa? Times 10 to the power of 3 moles CaCO3. What's going to happen to these two things? Yeah, they're essentially going to cancel each other out. I'm going to add the exponents. It's going to get me a 10 to the 0, right? What's 10 to the 0 equal to? 1. So this is 9.99 moles of calcium carbonate. So you can deal with a kilo in all kinds of different ways. You could have put 10 to the 3 at the beginning and calculated it out and got moles. You could leave the kilo there and get kilomoles and then convert it if you really need to. Or if it didn't really ask you for a particular unit, you could have left it in kilomoles. There's nothing wrong with kilomoles. It's just like talking about kilograms. All right? Okay. I'm not going to bother with that because it's really the same thing except I'm starting with milli. All right? I want to get to the last part of it where we're doing all 3 conversion factors. So, some more homework here. There's the question sheet on the handout on dealing with the molar mass. Then there's some textbook questions. But now I'm still going to do a couple, maybe 3 more examples where we're going to string together 2, maybe 3 of our conversion factors to go from, maybe mass eventually to entities. I'm just looking at the time. I wanted to kind of skip this one because I'd like to give you a little bit of time, hopefully, to do a couple of practice problems and ask me any questions. Okay. Those answers are in the margin. So calculations involving mass, entities, and grams. Okay. So now we're going to put it all together. The key to doing these is being able to know your conversion factors and what they can do. I do not have a conversion factor that goes from grams straight to entities, so I can't do that. So what do I have to turn the grams into first before I can get to entities? I have to convert it into moles using, and then I will do another step and convert it into entities using Avogadro's number, and I don't get you to chant Avogadro's number. I don't know why. Avogadro's number. We could. It would be fun. If we were to turn this into a map, I would say that I'm starting with grams, and I want to get to moles, and that is the molar mass. And then I can go from moles over to entities, and that is Avogadro's number. So let's gather up our conversion factors. Number one, molar mass. Need the formula? Got to do that off to the side. This is one that you will be seeing over and over again, and therefore, I do not necessarily need to see it each time, but you've probably already got it figured out. Water is 18 grams per mole. And so when you do a water, you don't need to show me all those steps. We're going to use that over and over again. It's 18. 5.0 grams H2O. Take it step by step. I can only convert into moles. Somebody tell me where I'm going to put things on this chart. Where are things going to go? Tyler, where are things going to go here? Yep. Yep. Now, that would leave me with moles. But I don't want moles. I want entities. I've got it on a chart over there. What's going where in order to get me to entities of water? Yep, Brody. That'll do it. Now, when you have multiple conversion factors, all right, anything that's on the top is a multiplication, but anything that's on the bottom is a division. It doesn't matter the order in which you do it, because multiplication and division in Vedmus is, you know what I mean, it's the same thing. There's no order for that particular thing. So 5.0 divided by, so press the divided by button, 18.0 times 6.02 exp23 will get you the correct answer, or 5.0 times 6.02 times 10 to the 23 divided by 18 will get you the answer. Doesn't matter what the order is, as long as we've got everything in the calculator correctly. I will take that answer, and it's looking like, how many significant digits am I rounding this thing to? Janessa? Right? See that one in the front? 2? All right. So what do we got? Janessa, you got a number? 1.7 times 10 to the 23, and that's entities of water. What kind of entity is really water? We haven't been doing this, but what is an entity of water called? Yeah, water molecules. That's a very powerful thing. Think about that. We can now weigh out some water on a scale, and we can figure out how many molecules are in that water. That's quite amazing. That gives us the ability to literally count out those little tiny things, not directly, but through the mole. Question? right here, 5.0. That number at the very beginning that was weighed on a scale was weighed with a scale that only had one decimal place on it. It wasn't weighed with a scale that had finer markings on it. You can buy scales that have all kinds of ability to measure different decimals. All right? The scale we used was not very accurate. It only contained one decimal place worth of information. We have scales that contain one decimal place that we let the grade 9s use and the grade 10, because grade 9s and grade 10s, they're rough. They break things. They're worth about $100. We have scales that we use in this class that have 2 decimals. They're worth about $500. I could order a scale that will measure to 3 decimals. They're worth about $1,000. I used scales at university that will measure to 4 decimals. It's so sensitive that as you're breathing and measuring, the numbers are fluctuating because of the air heading it on the top. You have to actually close it in a little building, a little dome. I guess not a building. You slide it open, and you look through a glass, and you carefully put it on the scale, and then you close the window, and you hope a truck doesn't drive by, because if it does, it's going to shake the table enough that the numbers are going to go all haywire. Those scales are about $10,000. We used the grade 9 scale. We were cheap, only $100, which means my answer can be no greater than 2 decimals because of my cheap scale. Okay? And that's where it comes from. Okay? All right, let's do another one. Just put B. You don't have to rewrite it. Just B. Oh, I'm looking at the time. Yeah, we'll do that one quickly. It's the same as the other one, except I've got a kilo on there. But it's not a big deal. I just want to jump ahead to that one example that I want to get to. No, that's okay. We'll do one more example after this. What am I going to need? What am I going to have to find before I even do anything? What have we been calculating first? Molar mass. Let's get that molar mass. Notice I've got 2 sources of nitrogen in this. I wouldn't put them together. I would just put an arrow for each individual nitrogen. I wouldn't get too creative on that. It's not very heavy. Yep, what do you got? 80.0? Cool. Now, last time I left the kilo, and I ended up with kilomoles. If I leave the kilo here, what am I going to end up with? Kilo entities in the end. That's kind of silly. Kilo. I don't know where that came from. Kind of a silly thing, kilo entities. So what I would suggest doing here right off the bat is put 1.00, and let's get rid of that kilo, because I don't think kilo entities we'd have to put it at the end. Let's do it at the beginning this time. So instead of writing kilo, what can I write? Times 10 to the, did they say -3 or positive 3? That's a positive 3 grams. Now we'll just go from there. Then we'll just get entities, because we got rid of the kilo. And that is NH4NO3. On the bottom, I need the 80 grams. Whoops, I didn't want a decimal place in there. I'll squeeze a 0 in there. 80 grams, 1 mole. And I am really tight for space. I've got to get rid of the moles. 1 mole, 6.02 times 10 to the 23 entities. Okay? Now, our calculator abilities. 1.00 times, or EXP 3 divided by 80 times 6.02 exp23. Again, we could get an estimation, 3 and 3, 26, divided by a 1, 25, some approximately 25, I would think. Brody, what do you got? It's looking like 3 significant digits. And these are formula units. Just put here entities. Okay? Right? I want to do one example of going back the other way. You know what? Just to add one extra thing that I don't have in my example, we could turn this into individual oxygen atoms. What if I had entities of NH4, NO3, and I wanted just oxygen atoms? What conversion factor would I need to finish this? If I just wanted oxygen atoms, now I need to create that one out of this formula. Janessa? How many oxygens have I got in here? That's okay. Yeah. 3 oxygen atoms over 1 NH4NO3, and I just multiplied by 3, and I'd have oxygen atoms. Okay? I didn't have an example that has one of those built in, but that's how you would do it. All right. I want to just do one example, and I'm going to just jump ahead to B. And this is the last one. Now, the pitfall of me showing you how to use molar mass and then how to use entities and molar mass together is that some of you will want to use every conversion factor in every question. Don't do that. Some of them will be simply mass to moles. Then all you need is the molar mass, right? I could throw a curveball and give you a question on the quiz that was just moles to entities, and then all you need is Avogadro's number. But if I'm going from mass to entities or entities to mass, I need the 2 steps. So you really need to memorize what the job of each conversion factor is, and then depending on what you need to do, you need to ask yourself, do I need every conversion factor or do I not? All right? We want to find the mass, and we're starting with molecules, which is essentially entities. Entities. If I were to make a map, I'd say I'm starting with entities, and what can I convert those entities into? I can convert it into moles, and what is the conversion factor that does that? Go ahead, Haley. Avogadro's number, excellent, that's that big number. I can then go from moles to mass, and, oops, that's supposed to say mass. How do I go from moles to mass? Oh, I've done such a poor job of indoctrination. It sounded so good at the beginning, now I had a trickle of molar mass. Tiniest little molar mass there I've ever heard. Let's get the molar mass. Ready? Oh, I already did this one. What's the molar mass of carbon dioxide? 44. We're going to cheat just for time. 44.0 grams per mole. Carbon dioxide is another one of those that we're going to calculate all the time. We like to do calculations involving combustion reactions. So you're going to deal with water and you're going to deal with carbon dioxide. 2.2 times 10 to the 50 entities of CO2. What's going where in my next conversion factor? Yeah, Janessa? If I put the 6.02 times 10 to the 23 over 1 mole, I will have mole on the bottom, and I will not be able to cancel out entities. So I cannot have mole on the bottom. Janessa? Yes. I look at that entities, 6.02 times 10 to the 23 entities. It's the units that guide where I put things. The unit I'm starting with, I need that unit on the bottom per 1 mole. Now I have moles. I eventually want grams. What's going where? You're going to tell me what's going where? 44 grams over 1 mole. 44.0 grams over 1 mole. The moles are gone. And I'm left with grams of CO2. That's what I wanted. A little estimation of the power of 10. 10 to the 50. 10 to the 23 on the bottom, which means I've got to subtract, which means I'm not at 25. I'm about, what, 28? Is it 28 about there? 10 to the 28 is the ballpark. So you can always do an estimation. What do we have? Maggie, what do you got for a number? Yep, that's a lot of grams. But 10 to the 50 is a lot of molecules. All right? We might be talking about the amount of carbon dioxide in the atmosphere, perhaps, right? If that was a question involving the entire atmosphere, right? That could be estimated. Okay, and that brings us to the end, and that essentially means that you can do that in the rest of that sheet on the mole. All right? Your homework is the rest of the sheet on the mole. We've got a good solid 10 minutes. You can get started on it. Notice, though, each step walks you through some baby steps, right? One will be mass to moles, just molar mass. You know, one might be just entities to moles, Avogadro's number. But if it's mass to entities, then you need the 2 steps. Okay? That page right there is the stuff that our little quiz on Friday is going to be on. Okay? That page right there is the stuff that our little quiz on Friday is going to be on. And that's just to make sure that you do it and try it, because this is important stuff for when we move on in the future. Yep.
When do we usually submit one?
If I have, let me just stop this recording for a second, and then I will address that, because I don't think I need to save that data.